So Algebra 2, 8.4, logarithmic functions. What we're going to have here is that we have log functions, and log functions are just a fun way of expressing exponents, where the log is the actual exponent. As you can see here, x is an exponent here in the exponent form, but when I go over to log form, it's equal to the log base b of y. These are interchangeable. So part of your homework is going to give you a log, write it in exponential form. Give you an exponential form, write it in log form, and vice versa. So you have to kind of be able to go back and forth on these. So let's test it out. Let's test it out with, say, log base 3 of 2 equals, well, not 2, let's say 9, equals 2. And we switch this to exponential form. So become very familiar with this idea that you're going to take log form over here, and it's b, the base of the log, to the x power equals y, where x is what it's equal to. So that means 3 to the second power is equal to 9. 3 squared equals 9. Is that true? Yeah. It's true. And then you're going to also have to go to something like 2 to the 4th power equals 16, which is true. 2 times 2 times 2 times 2 is 16. Can you write that in log form? Which means that it's going to equal log, what's the base of the exponent? Going over here, what's the base?
2.
2. So log base 2 of
4.
16 is equal to. So that's one section in your homework. Another one, or another part of logs, are special ones. Special logs. Like log base b of 1. Doesn't matter the base. I don't care what the base is. It can be a 5, it can be a 10, it can be a 2. Bases are not negative, so it's always bigger than 1, or it's bigger than 0. And we generally stick with a whole number, but sometimes we'll get into irrational numbers as well, and you'll see that in a second. Or in a second. But anything, think of this. What if we don't know what it's called? We'll call it x, right? And if it's x, if I switch this to exponential, right? That would be b to the x equals 1. What does x have to be?
1.
B to the first power would be b then. But b to what power
0.
is equal to 1? It's 0. And so x would have to equal 0. Where x equals 0 then. So actually, I know I did this all backwards, but it would equal 0. So log base b of 1 of anything is always equal to 0. Another cool one. Log base b of b is equal to 1. B to the first power is b, right? Think of it switching it. If I switch it, it'd be b to the first power, which is equal to b. Those are technically, that one is more of your inverse idea. And so, what they're going to have you do, though, is evaluate. They're going to have you evaluate. What about log base 3 of 81. They want you to use the fact that log base b of b ends up being 1. Or, wait a minute, I'm going to back this up just a little bit. Log base b of b to the n is equal to n. That's the true inverse. If these are the same, the exponent is your answer. that's going to help us with our next problem here. Our next problem is log base 3 of 81. So the question you want to ask yourself is, can 81 be 3 to some power?
No.
And the answer is yes.
Yeah.
3 to what power is 81? 4. So log base 3 of 3 to the 4th, these are the same, so the answer is 4. Pretty cool. Log base 5 of 0.04. Oh my goodness. I don't know if I like this one. 0.04. Can I actually write that as 5 to some power, possibly? Or wait a minute. 0.04. That's 4 over... If I write that as a fraction, how do you read that? How do you read this number? That's tenths, hundredths. So that's 4 100ths. Can you simplify 4 over 100? I hope you can. Isn't that 1 over 25? Wait a minute, 25? 25 is a power of 5, isn't it?
Yes.
That'd be equal to log base 5 of 1 over 5 squared. Now, by chance, could I bring the 5 squared to the top?
Yeah, because there's just a 1.
Because there's a 1 there, but if I bring a power to the top, it's going to become negative then. So this is log base 5 of 5 to the negative 2. And the whole reason I did this was to get the 5's to be the same. So now the answer is equal to negative 2. If you put 5 to the negative 2 power on your calculator, you will get 0.04. So the answer is negative 0.2. Or negative 2, sorry. As I alluded to earlier, there are going to be bases that are decimals or fractions and different things. That's fine. But the two logs that we generally talk about are going to be the common log and the natural log. The common log is log base 10 of x, or of something, log base 10. It's so common, we sometimes just drop the little 10. So this little 10 is gone. If you don't see a 10 tucked away as a base, that means it implies the base is a 10. So if you needed to get rid of it or cancel, like if I wanted to know what's the log of 100, that means you know that you have to get 100 to be base 10. So you can cancel them. Now, natural log, on the other hand, is log base e of x. E is a naturally occurring number. That's the natural log. 2.718. We just did that. But it's so commonly used, we use ln instead. So if you see an ln, the ln takes the place of log base e. Goes from 4 letters to 2 letters. Just makes it that much simpler, easier to use. So now what I can do is ask you the natural log of e to the 4th. What is natural log of e to the 4th? How can I simplify that? What's the base of the natural log?
10.
No, natural log. It's e. So really, guys, there's a little e down here, which means they would cancel and it equals 4. So you'll like those. Also, since I'm on this page, I would like you guys to actually take your calculator out and evaluate. Put log of 100 on your calculator. Make sure you know where they are. You can find it. If you're using the old one-step calculators, you have to put 100 in first and then take the log. You should get an answer of 2. Now, not everyone's going to be an answer 2. Your book wants you to round to 3 decimal places for some of them. So make sure to follow what the book is asking you to do. You also can do the natural log of e to the 4th. You should end up with 4, as we have stated here. So make sure you know how to put that on your calculator. We have one more inverse log. And what happens if the log is the exponent itself? And they happen to have the same base as what it's on. So if these bases are the same, the answer is whatever's inside the log. So whatever it is, it's x. So 2 to the log base 2 of 3. The 2's will cancel logs out, and your answer is 3. So whatever's in that position comes down, 3. Okay? Doesn't matter what's in that x position, that is your answer. Finding the inverse of a log. To find the inverse of a log, it really is just the exponential form. But when you switch to exponential form, you also need to switch x and y. So these steps, 1 and 2, can be done in any order. I always say, because just like before, we always switch x and y. Here we go, switch x and y, and then switch to exponential form. And then just for the last good measure, we always solve our equations for y. So solve for y. So let's do the inverse. Now, it says, number 1, switch x and y. X equals log base y plus 3. Notice that the x plus 3 is not in parentheses here. So that means you're doing the log of x first, and then you're adding 3. Now we're going to switch it up so it's log of y plus 3. And now you have to solve for y. So since it's not y plus 3, they're separated. To solve for y, I need to isolate the log first.
So subtract 3.
So I got to subtract 3. So you get x minus 3 equals the log of y. Oops, sorry. I changed it, guys. You see it? It's not log, it's supposed to be natural log. Sorry. Which is a log, but it's log base what? Natural log is log base e. Okay. Now we need to get rid of the log. And to get rid of the log, you switch it to exponential form. Now, we talked about, I just said it, that this is really a little e there, right? So natural log can be log base e. When I use this side over here with the x minus 3, it goes all together now. So you can act like there's a set of parentheses on there because we need to add that eventually, possibly. But the answer would become e, right? The base to what it equals, which is x minus 3 equals y. That's the inverse. So what I did here is I kicked it up just a little bit. Log base 2 of x, the quantity x minus 3 plus 2. I want to find the inverse of this. So number 1, switch x and y. Yes? Notice this time, though, that there is a set of parentheses with the x minus 3, which now becomes y minus 3. And again, now that is actually part of the log. So this whole log base 2 of y minus 3 goes together, which means get rid of the 2. To get rid of the 2, you subtract it. And when you subtract it, now the x minus 2 part goes together. So when I go to switch this, what is it going to look like? The base to what it equals, right? So it becomes 2 to the x minus 2 equals, what's inside the log? 1y minus 3. You're almost done. You got to get y by itself, so you will add 3. So y inverse, maybe even put the little negative 1 on it, is 2 to the x minus 2 plus 3. And wada bing, wada boom. You're good to go.